Hey there, Advanced Math. More expressions today. Today we're going to talk about expressions that involve the distributive property. Hopefully you recognize the term distributive property from the beginning of the year, but it's definitely an easy thing to forget, and a thing that gave us some trouble earlier in the year in some cases. So, write this down as the next title in your math notebook, then close it up and concentrate with me extra hard, because this is definitely an easy to forget topic, and I want to make sure we do it right here. Alright, so speaking of the beginning of the year, way back, like first, second week of school, we worked on some problems like this. 25 adults and 20 children will come to a party. An equal amount of adults and an equal amount of children need to sit at each table. How many tables could be set up? So what we did is we kind of said, okay, well, there's going to be 25 adults and there's 20 children, and we looked for a common factor, right? If I want to divide these up so that an equal number of these and an equal number of these are at the same table, then I need a factor that I can divide both numbers by. And so, like in this case, a common factor is 5. I can divide 25 by 5, and I can divide 20 by 5. And if I do that, I end up, of course, with, 5 adults and 4 kids at 5 tables. And we wrote this another way. We say, okay, well, if I divided this by 5, and I divided this by 5, I could rewrite this expression, 25 plus 20, using the distributive property like this. I could say, well, it's going to be 5 tables of 5 adults and 4 kids. 5 times 5 is 25 adults, and 5 plus 4 is 20 children. And so these two expressions are the same thing, right? If I had order of operations, this would be 9 in the parentheses times 5 is 45 people. And this would just be 25 plus 20 is 45 people. They both equal 45. They both show me the same thing in different ways. This shows me all the people. This shows me how they're divided up. 5 tables with 5 adults and 4 children. So the distributive property works like that. It tells me that I can take this and I can rewrite it as 5 times 5 plus 5 times 4. I can do the multiplication of this one and the multiplication of this one and get 25 plus 20. That's the distributive property. I can distribute this 5 times, really, to that and to that. That's how it works. So that's back from the beginning of the year. So we're going to do some expressions that involve the distributive property today and write it a couple ways. So let's go back to vending machine Jason. He made 6 trips to the vending machine in yesterday's lesson. So let's say this. So the next week, let's say this. He bought some chips for $1.50 a bag. Don't know how many. And he bought some M&Ms for $2 a bag. Don't know how many. And he did that 3 times. So the way I would want to write that expression is, if it were me, so again, we have $1.50 times however many bags of chips he bought. I don't know how many it is. $1.50 times C for chips. Plus $2 times however many bags of M&Ms he bought. Don't know how many, so I'm going to use a variable. $2 times however many bags he bought. And he did that all 3 times. So he did this 3 times. I'm going to write it 3 times like this because, again, I'm trying to get you guys used to multiplication usually being written at the beginning and usually not having a multiplication sign, just because that's kind of the convention that you'll see the most. But it wouldn't necessarily be, if you were just writing an expression, this isn't really wrong. It's just, especially in this case with the distributive property, I'm going to put it the other way. So he did all that 3 times. So that's one way I can write the expression for Jason's trip to the vending machine. However, I can write it another way too. So whenever I see a value times a sum in parentheses, a lot of the times that triggers to me that I can do the distributive property. So let me go the long way, and let me show you why the distributive property is nice and goes faster, right? So what this really tells me, this is repeated addition 3 times of this. So what I really have is this 3 times that, plus that a second time, plus that a third time. And you'll remember from yesterday's lesson, I can rearrange these and I can combine all my m's and get 6 m's, 6 times however many M&Ms we bought, to calculate his price. And then I can combine all my chips. And that's really what I'm about to do. I'm just about to do it faster. So this is where I'm going to end up. If I do repeated addition, 1, 2, 3 trips where he does this. Here's where I'm going to end up with another expression to calculate his price. But, so distributive property, I can do that faster than writing out the repeated addition and combining. So when I see this, just like if I go back to the last question when I had numbers, I end up with 5 times the first term plus 5 times the second term. 5 times 5 was 25, plus 5 times 4 was 20. And so that's a shortcut you can take with the distributive property to do that. So I can say 3 times $1.50 C is going to be $4.50 C, and then 3 times the 2M is going to be 6M, which is what I got over here. Let me show you an even cooler way to do that. Blast back from 4th grade. So what I see here can also be done with an area model. 3 times $1.50 C plus $2 times M. And I can fill it in like this, right? 3 times that is going to be repeated addition, $1.50 C plus $1.50 C plus $1.50 C is going to be $4.50 times C. And then 3 times 2M is going to be 2M plus 2M plus 2M. Repeated addition is 6M. And now, just like you would do with all numbers, you would just add together what's inside your area model, which I can't do. I can't combine M's and C's because they're different values. And so I get a third way. I get this. So this is one way I could write an expression for how much money he spent. And this is another way for how much, way to show how much money he spent. So this I get from here to here by applying the distributive property. 3 times the $1.50 and 3 times the 2. All right, let's do one together. Open up your notebook, and let's do this. Amanda went to Publix. She bought some cheese for $4 a pack, and she spent $25 on other stuff. Write 2 expressions that show how much she spent. Wait a minute, I need her to do this more times, so write this in here for me. Sorry, I didn't write this in. Let's say she did this 3 days in a row. Let's say. So I forgot to type that in there. So write 2 expressions that show how much she spent. So the first thing, I want to see how much she spent. So she spent $25 on other stuff. Notice I have a value there. There's no missing unknown value. I just know she spent $25 on some stuff. I'm going to skip the dollar sign for the expression. So she spent $25 plus some more. She also spent $4 per pack of cheese, and I don't know how much cheese she bought. So she spent $25 plus 4 times however much cheese she bought. she did this 3 days in a row means I'm going to take that whole thing and multiply it by 3. So she spent 25 plus something 3 times. So this is one way I can write the expression. So this is, I'll just leave it there. That's form number 1. So we want 2, right? So let's explore some ways we can get rid of these parentheses with the distributive property. So I'm going to show you 3 different ways to do it like I did last time. So one is I can think of this as repeated addition, R add, and that's going to be 25 plus 4c plus the second day, 25 plus 4c, plus the third day, 25 plus 4c, which I can rearrange to be 25 plus 25 plus 25 plus 4c plus 4c plus 4c, which is 75 plus 4, 8, 12 times however much cheese she bought. That's one way I can do it. That's kind of a long and annoying way to do it. So it's not the way I'm going to prefer to, and especially if it was like more than 3. If she did that like 10 times in a row, that would get pretty obnoxious. Area model, second way. So let's try that. So area model, I'm going to say that's 3 times 25 plus 4c. 3 times 25 is 75. 3 times 4c is 4c plus 4c plus 4c, which is 12c. I get that, 75 plus 12c, just like I got here. And third way, if you really want to shortcut it and just use the distributive property, you can distribute the 3 and just say 3, I need more space, sorry, back, 3 times 25 plus 4c is 3 times 25 plus 3 times 4c, which is going to be 75 plus 12c. All these get me to the same place, you'll notice, right? It's just a matter of which one you're comfortable with understanding why it gets you there. You know, this is probably the fastest, but I only want you to do this if you kind of understand where it comes from, that I'm really doing this, or that I'm really doing this behind the scenes. So this is sort of like the fast algorithm way to do it. These are meant to help you understand where that comes from. All right, that's the distributive property in expressions. If this was tough for you, again, please go watch this again. I'd love for you to come to class like with a pretty good understanding of how these first 2 examples work. But once you've written this down and once you're there, see you tomorrow. Can't wait.